Canisius College. Okay, got it. From Canisius College in 2011 and an MS in Wildlife Ecology from the University of Delaware in 2013 and a PhD in Ecology and Evolutionary Biology from the University of Oklahoma. And also spent 2 years as a postdoctoral research fellow at the Cornell Lab of Ornithology from 2017 to 2019. He now is the director of a lab at CSU, which is, I'm going to call the Aero Ecology Lab, Aero Eco Lab. And that, that's the place where he studies migratory birds, and he's going to tell us all about that. He's also an assistant professor at CSU in the Department of Fish, Wildlife, and Conservation. So a busy guy. The lab studies migratory birds and employs a range of remote sensing tools, including the use of weather surveillance radar data. And his seminar is going to highlight his team's work pulling these pieces of information together to better understand how migrants use nighttime airspaces and to determine where and when migrants are impacted by artificial light and how radar can be used to forecast and mitigate these impacts. And I just want to say that the use of radar to observe bird migration was a big breakthrough. It was never done before, oh gosh, a number of years ago, and it has just yielded all kinds of data. So Kyle, could you please unmute yourself and go ahead with your presentation. Thank you so much for coming tonight.
Sure, yeah, thanks for having me. Thanks for the introduction as well. You can see my screen and hear me okay?
Yes.
Perfect, thanks. Okay, I'll try to keep track of the chat here as well as I progress through the talk here. If I don't get to it, I'll try to get to questions at the end as well. And I think we'll have time for a good conversation. So yeah, thanks for having me. I'm really excited, certainly learning things already, just listening to the conservation updates. And I'm really excited for some of the projects that we have coming online and trying to interact more intimately with Denver Audubon as well, some of the things we have going on our lab here at CSU. So I'm just going to jump into it to give you a little bit of an outline of where we're going with the seminar, and then hopefully start working through some of the details about bird migration, the nocturnal side of bird migration, and the tools that we're using in my lab to try to characterize bird migration. So first one, as Polly mentioned, thinking about this outline here, that radars can detect critical measures of aerial migratory movement. So hopefully you'll be quite convinced that this is true by the end of my talk here. Second one being artificial light negatively impacts migratory birds. So we already heard a little bit about this from the programs that all of you are working on at Denver Audubon. So this probably won't be too much of a surprise, but giving some of the evidence towards this statement and studies we worked on across the US. And then lastly, how we can utilize this understanding, the use of radar data to try to predict migratory movements in real time, allowing for applied conservation activity. Okay, so hopefully that gives you a good sense of where we're going for the next, 45 minutes or so. Okay, so as Polly said, I run the Aero Ecology Lab here at CSU. And you might be asking, well, what the heck is aero ecology? That's a fair statement, and it's a relatively new field in this capacity of trying to understand airspaces as a habitat. I would argue that classically we've spent the last 50, 100, 200 years studying migratory birds, thinking about terrestrial habitats, thinking about these birds as they settle into the landscape, how they utilize stopover habitats, and then we go out and we see these awesome birds that excite us. Or maybe these birds use aquatic landscapes, thinking about bodies of water, waterfowl, or shorebirds, and how they utilize that. Again, still ground-based habitat, but in this sense, aquatic. My lab thinks about airspace as a habitat, thinking about this area is the medium that these birds have to utilize to go to and from their wintering and breeding grounds. And the study of these aerial habitats is known as aero ecology. So hopefully that sets the scene of what we'll be talking about tonight. I'm, just probably as excited as all of you about migratory birds and bird watching. I started as a bird watcher and transitioned into a scientist, but still love bird watching as my primary hobby as well. So moving around Fort Collins, trying to see migratory birds as they pass through times like now, also in the springtime, and getting excited for when these birds come through. So when we think about the diversity here, it's quite astounding. At least, globally, there's around 10,000 species. Of those, about 19% are considered migratory in some capacity: long distance migrants, short distance migrants, altitudinal migrants, you name it. About 20% of all bird species are considered migratory. So not necessarily a rare feat by any stretch of the imagination here. When we think about North America, however, we could probably predict that that number is going to be a little bit higher than the global average. A lot of bird species diversity is captured in the tropics. So some of those birds can reside in the tropics all year round. They don't necessarily have to migrate. In North America, obviously, the picture is going to be a little bit different, where we have, sometimes inhospitable winters are going to push those migrants out, and then they're returning in the spring and summer for the flush of resources that North America has to offer. So of our terrestrial species, we would say about 70% are migratory. So that is, they could migrate during the day, they could migrate at night. Nonetheless, of our species, of the 600 or so species, about 70% are considered migratory. Now, to get to the question, the poll that you all took at the beginning of the Zoom session here, we could then delineate of the 70% that are considered migratory, do they migrate during the day or do they migrate at night? When we break down those numbers, we come to a higher percentage here. About 80% of the birds that migrate in North America migrate under the cover of darkness. And there's various reasons for that, and we could get into a discussion about that. But nonetheless, it's important to know that the vast majority of our birds that we're excited to go out in the morning and see are moving at night. So that presents a number of challenges, however. We're trying to study these birds moving at large scales, thinking about many individuals migrating at night, not tens of individuals, not thousands of individuals, but hundreds of millions of individuals moving at continental scales. That the fact that they move at night presents a little bit of a logistic challenge. So the way that we try to get around this is to use a tool, namely weather surveillance radars, to capture what's going on at night. And weather surveillance radars are engineered, designed for detecting weather phenomena. They detect rain droplets in the airspace, they cast out radiation, that radiation hits rain droplets, and that radiation is returned back to the radar. As it turns out, most birds, and like most living organisms, are largely composed of water, just like rain droplets. We could think of them, in this case, like very large rain droplets that are moving through the atmosphere. So we have this great system, this great array of tools for trying to capture the magnitude of migration, the speed, the direction, where and when it's occurring across the continental United States. So if you've never seen this, images of this, I just want to orient you a little bit with what we can do and how we can visualize nocturnal migration. So just to set the scene here, we're in southern Florida. There's a white point here in the middle of the display. That is where a radar resides in Key West, Florida. So there's a radar sitting there on the island that's spinning day in, day out, trying to sample the airspace. You can see Cuba to the bottom of the screen, mainland Florida to the north at the top of the display here. So what I'm going to show you, the radar sits right here. It's called KBYX is the name of the radar. All the radars have a 4-letter code, this one being KBYX. And what I'm going to show you here is the onset of nocturnal migration in the Cuba, Florida area, birds coming through the Caribbean. So I'm just going to let it play here. You can see some birds taking off from the islands, and then we get this large secondary wave. And this large secondary wave is birds taking off during this April 23rd, 2020, taking off from Cuba, flying north and moving through the airspace, coming into mainland Florida. So we don't know from these radar data which species are necessarily in the airspace. It doesn't tell us which species are up there, but it gives us a good indication of the magnitude of migration. So not, like I said, thousands of individuals, but millions of individuals coming through these airspaces. So a tremendous volume of birds. In this time of year, we're talking about things like warblers, grosbeaks, thrushes, buntings, moving through under the cover of darkness. So this is one radar station, and it's for one night. These data are collected every 5 and 10 minutes across many stations across the US. So in fact, when I said many stations, it's about 143 stations reside in the lower 48 states, as you can see here, denoted by the white dots. The challenge that we face with what we're trying to do is really to disentangle the signal that these radars were designed to capture, namely weather phenomena. In this case, what we're looking at is not migratory birds, but in fact precipitation. So the intensity is shown by this color scale. So the yellows, oranges, and reds are going to be areas of more intense rain than the areas of the greens and blues being lighter amounts of rain. This is what you would see if you turned on the Weather Channel, for instance. You'd see these data looking just like this. Meteorologists work really hard to just show you these data. The reality is that we can actually go into the raw radar signal and see what was already removed. So what actually is in these raw data is something like this. What just showed up here are birds moving, again, under the cover of darkness, moving through the airspaces of the United States. So our job is to do actually the inverse of what meteorologists work really hard to do. We try to go through, remove, identify, isolate all of the precipitation, and then maintain that biological signal. And in this case, the biological signal being specific to migratory birds. So hopefully that's clear. When we talk about this at large scales, we're saying birds moving under the cover of darkness. The reality is that the landscape has changed quite dramatically in the last 20, 30, 40, 50, 100 years, and namely in the face of light pollution. So it's not this landscape void of structure, aerial structure, thinking about structures like communication towers, through skyscrapers, but also structure in the form of light pollution and where it resides across the United States. So what I'm showing you here is a satellite view of the terrestrial landscape, and the areas in yellow are areas that suffer from a tremendous amount of light pollution, generally places where people live in urban centers predominantly. So I'm just going to start with a small scale example of a study we did a number of years ago now. That's quite timely as well, what we just went through with the anniversary of the September 11th terrorist attacks. So we'll zoom into New York City. And we know New York City can be also a hotbed for migratory birds, right? That if you go and talk with folks around New York City, where do you go to go see warblers in the spring? Or where do you go to see thrushes coming through in the fall? You're going to go to Central Park. There's habitat there. We know the birds are making landfall into the habitat that is still available. But we also know from what we've been describing is that these birds don't land in this landscape, in this urban landscape, when it looks like this, but rather looks something like this, with a tremendous amount of light pollution changing the actual topography of the nighttime landscape. In one night out of the year, the light pollution is actually tremendously elevated at a single location. And that single location resides in Lower Manhattan. I think this will become quite obvious what this is, but this is one of the towers of light, denoting and remembering, signifying the twin towers that fell on September 11th due to the terrorist attacks in 2001. So these towers of light, again, this being one of them, are made up of about 44 spotlights. And you can see these twin towers of light from, upwards of 60 miles away on some nights, and they cast upwards of 4 miles into the atmosphere. So on some nights, the light pollution is stronger, cover or fog that might be, blanketing lower Manhattan. But often it looks something like this on a clear night. So we know probably from, a cadre of studies that light pollution can disorient and disrupt bird migration. But this is on a pretty extreme level. There's really not light pollution to this magnitude. And it offered a unique test bed for trying to understand what is the draw of these lights for birds that are coming through in fall. If the lights are turned off, do they quickly pass on through the area? Do they linger around for a while? So what I'm going to show you here is a short video I took, probably 5 years ago now. And I'm standing beneath one of the towers of light looking straight up into the atmosphere. So you can see the concentration of lights as they go up into the sky here. So as I play this video, hopefully you can see it on your end. You can see some things floating through the lights here. It looks like insects here, but the reality is that this is almost exclusively migratory birds, and very specifically warblers on this night. This is a pretty typical phenomena when we go there and do this monitoring, that we see thousands of birds attracted to these lights, generally upwards of 95% warblers that are being attracted to the lights here. You can see them coming in and out. The challenge here is actually quantifying all of these birds. Visually, we can see some of them, but they dip in and out of the lights. It's hard to get a good estimate of what's going on here. So that's where some of the tools that we have at our disposal, namely radar data, can help answer some of those questions. Before I jump into how we did this monitoring, I just want to back up with a little bit of the conservation message here. So just to orient you with what the map is showing you, you can see the outline sort of through the transparency of lower Manhattan. In lower Manhattan, the tribute and light resides at the top of a parking ramp. And the folks at New York City Audubon have really taken it upon themselves to do this monitoring. They work really closely with the organizers of the tribute and light. And they came to an agreement very early on in this memorial that birds were being attracted and no one wanted to see, birds colliding with surrounding buildings. So they came to an agreement that if visually 1,000 birds were detected, the lights would be turned off for 20 minutes. After 20 minutes, the lights would be turned back on, and then we'd go through that process again to see, maybe the birds never concentrate again, maybe they pass on and head back south, sort of continuing their migration journey through that night. So that's the exact scenario that we'll talk about right here. So this is a radar depiction showing here in this image. This is from September 11th, 2015, and the timestamp here is 10:12 p.m. That's when the radar sample was taken. From this radar sample, we're estimating around 500 birds surrounding the tribute and light. So that's probably just a good baseline for pretty active nocturnal migration. In this case, the lights have been turned off. This was one of those instances where we had a concentration of birds, the lights went off for 20 minutes, and then they're turned back on. So 20 minutes later, the lights are turned on and we get a new radar sample over lower Manhattan. And we're now estimating just 20 minutes later, around 16,000 birds surrounding the tribute and light. So a near magnetic pull of the birds from the surrounding aerial landscape into the tribute here. And through this process, we estimate across 7 years, effectively 7 nights, around 1.1 million birds were pulled in and out of the tribute and light. The good message here, though, with partnership with New York City Audubon, with monitoring throughout the entire night, we actually see pretty low mortality at this site. And that's in part because of the lights going on and off, allowing the birds to clear out, not circle and collide with lower structures and surrounding buildings. I see a question here from Claire about why the percent of sort of species is largely warbler dominated. It's a great question. We don't necessarily know the answer to that. It could be something about how these birds perceive light pollution. We do see other species come through, things like rails and shorebirds. sometimes thrushes, vireos coming through, some mimids. But why it's so concentrated for warblers is a great question. We don't have a good answer for you, but one of the mysteries that we have to hopefully unravel in the coming years. But great question. Okay, so just to back up, thinking about New York City, the tribute in light as a very focal, prominent, well-known example of light pollution, and now the intersection with migratory birds. Our next question here was to try to think about, okay, the tribute in light's a unique phenomenon. It probably doesn't generalize to light pollution across the United States. Our next step here was to try to come up with a catalog almost of what are the cities that might be the worst offenders for light pollution, but also have a tremendous amount of birds passing over their cities. So maybe it's not just the amount of light pollution, but also maybe geographically where that city's positioned, maybe in a migratory flyway. So we might ask the question, is New York City the greatest offender for light pollution in the confluence of migratory birds, or are there other cities across the US? So we set out to do that. And we started by looking at the top 125 largest US cities. It's probably quite obvious why we focus on cities, but nonetheless, the top 125 largest cities only account for about 2.1% of the landmass of the lower 48 states. However, they make up about 35% of all of the light pollution in the lower 48 states. So if we could make effective conservation practices at these small geographic areas, relatively small geographic areas, we could have a large impact in trying to mitigate light pollution. So we did just that. I won't get into the details during this talk, but I'm happy to field questions on how we did this. But nonetheless, we related using radar data at large scales, where and when the most number of birds are moving through cities across the US, and then how bright those cities were. And the product of those, we ranked the cities for spring and fall. So that's what I'm going to show you on this plot here, just to orient you a little bit. The left axis going up and down, the y-axis here is going to show the spring rank of those 125 largest cities. And then the x-axis, the axis going left to right, is going to show the fall rank. So are there in fact seasonal differences was one of the questions we had starting out. So a large city with a lot of light pollution, a lot of birds is going to rank somewhere in the top right. And then a smaller city with less light pollution, fewer birds flying over it would be in the bottom left here. So top right, intense light pollution, large cities, bottom left, small cities, low light pollution, low bird migration. Okay, so this is the way the points shake out, or the cities rank. You can see this dotted white line here. That means if the city fell on that 1-to-1 line, there was no difference across spring and fall in their ranking. You can see a lot of cities do have differences. The color of the points here denote the intensity of light pollution at that city. And then the size of the actual circle denotes the size scaled to the area of the city footprint. So the brightest city in the US, maybe hazard a guess here, but probably to no surprise, the brightest city is Las Vegas. The second brightest city in the US is New Orleans. Again, these sort of jive with probably our expectations. We can see where some Colorado cities reside. Here's Denver, a large city with a fair amount of light pollution creeping up towards the top here. Colorado Springs, a smaller city, obviously sort of ranking lower on this scale here. We can see anything below this 1-to-1 line shows us that the ranking is higher for the fall. And then anything above this, the ranking is higher for the spring. We can drill into some of the more prominent areas. So we can see, the areas, the most cities that come off of that 1-to-1 line are these cities here, showing us that the spring rank or spring exposure to these migrants is higher in the spring season at these cities. You could probably see a general trend that these are mostly Western cities on the Pacific Flyway. The reason for that, we could talk about the geography of how birds navigate flyways, but there's some looped nature that exposes these birds to light pollution more in the spring than they do in the fall. We can then zoom into the top tier of these cities here. So it's a little bit hard to disentangle. We zoom in and we see regardless of season. Number 1, 2, and 3 are Chicago, Houston, and Dallas. So I'm just going to do a little bit of a highlight here on Chicago, a recent bit of work we did in this city as well. So we'll start in Chicago, and we can take a look at the nighttime skyline of downtown Chicago here. So you can see the lakefront here in the upper left of this image, and then you can obviously see the urban sprawl of downtown Chicago. So this is an interesting area in that we have a tremendous amount of birds coming through. We have some geographic features here with a Great Lake concentrating birds along the coastline, and then this intense light pollution and urban sprawl. So we wanted to understand how these factors come together, and then look at a single building where long-term monitoring has been done, long-term monitoring in the essence of bird mortality events. So just to orient yourself here, thinking about the Great Lakes region, Chicago sitting on the south end of Lake Michigan. And then zooming into the coastline here, we worked in this area outlined in this box. And then zooming in even further, specifically looking at a single building, a convention center known as McCormick Place. And this area, over the last 43 years, monitoring has been done near Herculean efforts by Dave Willard and colleagues at the Field Museum of going out and monitoring for the last 43 years, waking up every morning, spring and fall, and collecting birds around this convention center. And across that period of time, over 40,000 dead birds have been found having collided with the building, the window panes on the convention center. So our questions here were thinking about light pollution. And the really unique piece of this story here, aside from the tragic loss of this many birds, is that it was a unique lens to study birds, thinking about collisions and light pollution. And this study was led by Benjamin Van Dorn, who is now a postdoctoral fellow at the Cornell Lab of Ornithology at Cornell University. And our question here was to understand how light pollution is maybe attracting these birds and then driving collision at this building. And Dave had the foresight to monitor, Dave Willard at the Field Museum, to monitor the light pollution at this building, counting whether or not areas, windows on the convention center were illuminated when he went out and did his check. What we found in this study is that having the illuminated window area on McCormick Place decreases collision counts by 11 times in spring and 6 times in fall. So if you ever needed evidence that turning off lights could reduce collisions, this is obviously a surefire example of this. We're not saying that Chicago generalizes everywhere across the US or that McCormick Place is a great representation of all buildings across the US or North America for that matter. It's a great example of how monitoring can be integrated with science, how having effective lights out warnings could hopefully mitigate some of these collisions. So we know that these collisions occur across spring and fall, but they don't occur regularly on every night, for instance. So we see periodicity in the magnitude of these collisions. And we can see this even in when we look at radar data, not necessarily collisions, but the periodicity in when birds are flying. So we're going to jump out of Chicago right now and jump back into Colorado. So I'm going to show you some radar data from the Denver radar from 2018, and this will be spring data. So the y-axis here will just be the indication of intensity of migration. Doesn't much matter how we monitor it or what the units are, just say low activity, low on the axis, high activity, lots of birds migrating, high on this axis. So these are what the radar data look like as a time series. So March starting out with sort of lulls of activity. And then as we get into late April, parts of May, we see some big spikes in activity. So it's these nights that likely are the dominant drivers for some of these mortality events. And that's also in part what we saw in Chicago. So we can say, how are these nights characterized? It might be the low end here, and this is what looks like in the Denver area at the high end of peak migration activity in spring. And it's these few nights that account for a tremendous amount of the migratory passage. This is true in most parts of the US, especially in Colorado. So in this season, it only took 3 nights for 50% of the birds to pass through this radar area or the Denver area. So they're moving through rather quickly and in big bursts. And these bursts occur in a relatively small interval of time, about 19 nights in this case. So we have, a little bit of a challenge there of trying to understand this little bit of a conundrum, right? It's a few nights that capture a tremendous amount of migratory birds. Does that generalize across, Denver? Does that generalize across Colorado, the Rocky Mountains area, or the entire US? And what we actually see is that's generally a takeaway message of where and when birds are moving through. They move through in a handful of nights, or maybe 10 nights or so. So we can look at this in a data format. So the bottom half of the nights for spring and fall only account for about 7% of activity, and it's the top 10% of nights that account for over 50% of activity. So thinking about spring being characterized by about 100 nights and fall about the same number of nights, it's about 10 nights across the US that more than half of the birds will move through any given area. So this is a challenging problem. We need to accurately identify a small portion of nights if we're trying to invoke some conservation messaging that are particularly important for migration. So as a general principle, it's hard to predict rare events, and that's exactly what we're trying to do. Okay, so let's just back up, detach from, if we could make this happen, let's just think about how we would do lights out warnings, or how we would interact with the public to try to advocate for lights out. So there's sort of 2 approaches here, or 2 broad approaches at least. We could say turn our lights off during a period of time. And that period of time hopefully is driven by some data suggesting that most birds fly through a given interval of time. So for example, we could say Denver turns off their lights from May 4th to May 18th. This is actually the interval of time that is specific to Denver. This is an interval of time that historically captures 50% of birds from the radar lens will pass through Denver during that period of time. We might call this a fixed selection, or a fixed window of time. It's not going to change from spring 2020 to spring 2021 to spring 2022. It's fixed. Historically, we learned this pattern is true for capturing the most number of birds, or 50% of birds. However, we could also do something at the other end of the spectrum, turn off lights during specific nights of high activity, those peaks in that time series. So we could say, for example, Denver follows a forecast of alerts. They turn off their lights for the night of April 28th, May 1st, May 3rd, May 4th, May 8th, for example. We could call this a dynamic selection approach, or a dynamic lights out approach. Some nights the lights are on, some nights the lights are off. It'd be best if the lights were off all the time, but we know that that might not be true, or there's competing interests. Okay, so if we followed these 2 dichotomies here, how does it actually shake out for how many nights it's going to take to capture 50% of the migrants passing through an area? So dynamic selection and fixed selection. Let's look at dynamic selection for spring. So what we find, probably to no surprise what we previously discussed, it takes about 10 nights to capture 50% of birds coming through in this dynamic fashion. Some nights are going to get an alert, other nights are not going to get an alert. About 10 nights will capture 50% of birds passing through, and they don't have to be night to night to night to night. Whereas the fixed selection approach, to capture an interval, a fixed interval of time, that interval is going to be about 19 nights long. So you have to advocate across the US, turn off your lights for the next 19 nights to capture 50% of birds coming through. We could look at this again now in the interval of time that we're in, fall migration, autumn migration. It's still true that it takes about 11 nights now to capture birds coming through if we used forecasts. And if we just use this fixed window of time, it's about 26 and a half nights now. So lights are going to have to go off for 26 nights continuous nights to capture 50% of birds for most areas of the US. So it seems if we're looking at efficiency for our lights out program, that alerts are probably a good way to go, but how do we actually generate these alerts? And that's where our project called Birdcast comes into play. So Birdcast is a collaboration between the Cornell Lab of Ornithology, my lab here at Colorado State University, and the University of Massachusetts. So what we work to do is leverage big data sets to then try to forecast nightly migration. The tool that we use is primarily radar data. Probably no surprise to what you've heard now. So we use these radar data to try to quantify nocturnal migration at the US scale. So there's things that we know from past studies, from intuition, about what drives nightly migration that might happen tonight, the night after, so on and so forth. So air temperature can be a strong predictor. The wind speed and direction are likely predictors that would promote birds to migrate tonight, for instance. And then a whole cast of other predictors have been well known to, basically fuel migration when it's favorable for a bird to head north or south, depending on the season. Okay, so our general approach here, I won't get into the details of how we actually model these things, but I'll give you just a schematic of what's done. We use radar data to learn the associations of when birds fly and which parameters suggest birds are flying. So wind speed, direction, barometric pressure, temperature, time of year, things like that. We link those with those conditions. We learn those associations. As long as we learn those associations, we use a fairly advanced model to do this. We learn those associations in a complex network. And then as long as we believe that part, we have confidence in this step, we can then add new meteorological data, basically. What does the atmosphere look like tonight? And how does that then translate to a bird migration forecast? So we use this schematic to make forecasts. It's good to know that this thing generally works, though, empirically. So what we can do is make predictions with the data we do have and see how our predictions relate to what the radar is actually measured. So this is a prediction now from about 5 years ago for the night of April 26, 2016. The areas in yellow are predicted to have more intense migration. The areas in black lower amounts of migration. And this is a prediction from a model that included none of the 2016 radar data. So it's a true prediction. And then what we can do is then relate what the radar actually measured. So hopefully you can see a relationship between the intensity that the radar measures and the areas that we make our predictions of intense movements. They generally align. So again, we can cherry pick any example that generally works. What we have to do is prove that it empirically and objectively supports these predictions. So we did this. This scale here, let me just take a step back. The scale that I'm showing you here is a metric known as variance explained, or R squared. It's a model performance metric. So the scale ranges from 0. Our model does no better than flipping a coin of saying birds will fly tonight or not, or all the way up to 1, meaning we make perfect predictions. We're the oracle of predicting bird migration. Generally, we don't ever see models that are at 1, and hopefully we don't see models that are down to 0. But a model here on this scale, we can already make a strong prediction that on this scale, we're doing quite well. So we're explaining 78% of the variance for the 2017 season. This is a spring migration metric here. We did this across lots of years, and what we saw is consistent performance across years. So we feel confident that we can make objective real-time predictions. So let's go back. We now have a system for making forecasts. However, that forecast does have some error in it. It's not always perfect. So sometimes we're going to make an alert and we didn't need to make an alert. We would just call that an error. So we can say, how many additional alerts are we making if we use this forecast system through Birdcast? And in practice, instead of getting 10 nights of alerts across the US, we might make around 14 nights of alerts. still lower than the fixed pattern. It's about 4 additional nights. In autumn, we have a little bit additional error in our model. So it's about 6 additional nights from it being a perfect scenario of capturing the fewest nights, but also capturing 50% of migratory birds. But this is quite exciting. We're doing considerably better, or we're capturing, fewer nights, but capturing 50% of birds coming through than this fixed approach. Okay, so following forecast requires fewer nights of action to capture 50% of birds. This was true across the entirety of the US at every radar station. So we could look at this in an idealized framework. This is what it would look like perfectly. Again, we said capture 50% of activity. That's an arbitrary metric in many ways. We could say we want to capture 75% of activity coming through Denver, for instance. And then we could say, okay, if we want to set our target at 75% of birds coming through, how many nights of action would we need? And we can trace that back on a plot like this. And then we could say, well, what is the status quo of just a fixed interval look like to capture 75% of birds coming through, or 50%? How many nights are we looking at? And then we can say, what is the forecast actually doing in practice? And hopefully, some of you have probably already seen this in practice, but we work on this page here. You can go to birdcast.info and see these migration forecasts, or you can go to the Aero Ecolab.com's website, my lab's website, where we also host a lot of these maps. So this is the forecast for where birds will be moving through, or where we're predicting birds will be moving through tonight. Across the lower 48 states, and we're estimating around 373 million birds up in the airspace. This is where we have lights out alerts. So the white hot areas don't always translate to an alert in some areas, and the dim areas on the migration intensity can also be an alert, because we have differences in migration intensity across the US. We could probably reliably say more birds will be coming through, Texas than Colorado, for instance. And that's the benefit of these lights out alerts. So this is for tonight, tomorrow, the night after that. So this is the intensity, and then where the lights out alerts are occurring at the US scale. You can also drill into state level maps as well. So thinking about Colorado here for tonight, tomorrow, and the night after that. So again, to no surprise, we're in peak migration. So we're getting a fair number of alerts coming through. Those will wind down as we progress later into the season. Let me just check the time here. Okay, so I'll just chime in here with some next steps of what our hopes are for this work. So we've been quite fortunate to receive some awards to continue this work. So our next steps are to really drill into habitats across the US, primarily thinking about urban areas. So thinking about aero ecology as this lens. So if we have this landscape, we might predict more birds coming out of forested patches than urban areas. And as more birds take off from these forested patches, those also start to translate into the radar data. So trying to use radar data to map and monitor habitats across landscapes at US scales, what are important stopover areas, for instance, and then relating how that translates into the passage of birds through urban areas, potentially thinking of these as ecological traps, a trap being the birds are preferentially moving into urban areas because of light pollution, but then suffering some consequence, maybe colliding with a building or just being delayed on their migration. So some fitness consequence or a mortality consequence, and then trying to monitor these things at US scales as well. And then lastly, I'll just touch on this project. We actually just got the notice that'll be starting last week, which we're really excited about. And I'd love to chat with folks on the conservation board here and committee of how we can engage on these topics. So the title of this project here is called Growing Convergence Research Can Improved Ecological Forecasting Accelerate Sustainability Transformation in Urban Lighting. So just the schematic of this project. Next spring, we're going to be launching with partners to talk about light pollution and strategies for mitigating light pollution in urban areas. We will use that information to motivate a national survey of attitudes of light pollution. And then we're going to be enhancing our forecast system through Birdcast to try to inform better lights out warnings. And then moving into the second phase of this project, having targeted messaging experiments in many ways like what we're doing, but actually trying to monitor what's going on. So through the 5 years of this project, continually meeting with partners for feedback on what's working and what isn't. And then doing very targeted experiments within urban environments, trying to shift human behavior, and then seeing if we can actually monitor that light pollution, hopefully seeing a reduction in bird collisions. And then with all of that knowledge after 5 years of trying to really continually enhance and inform these models that I've talked about today. So this is a list of the partners that we have involved so far in this larger project. This is a project between partners here at CSU, my lab, and Becky Nemec here at CSU, and Jeff Kelly and Carol Silva at the University of Oklahoma. So I'll just close on sort of that, at least for us, that exciting note of trying to apply some of these tools into communities. And I'd love to talk about how we can get more engagement with Denver Audubon as well in your community. So I'll close there with a whole cast of folks that have been really instrumental to this work, collaborators over the last 5+ years on these projects I talked about. Our funding sources from NASA and the National Science Foundation, and I'd be happy to take questions. I think I have time. So I'll stop there, and if there's questions, I see some in the chat already, but thank you very much.
Yeah, I think the first one that I've seen, Kyle, is the one from Asia Ellis, excuse me if I'm not pronouncing your name right, which is, are the nights of I think of the most migration changing, are getting earlier or later in the year in any noticeable way? And would you expect them to, given climate change?
Yeah, that's an awesome question. Yeah, so thinking through that one, we do see some shifts using these radar data. We've done other studies looking at the timing of migration. It does seem like, especially in the spring, things are advancing across the US. They're getting slightly earlier. The magnitude of that change is probably at the scale of maybe a couple of days across 25 years. So it's a small change, and that's generally true of these large scale phenology studies, that it's not shifting 2 weeks in advance. But the fact that it shifts at all when we're talking about billions of birds is quite important to recognize. But in this case, it probably doesn't yet impact the alerts or when those big nights are coming through. If anything, they might be slightly earlier, but still we're talking at very broad scales. I don't know if we'd be able to detect that with our data, but it's a great question. I see another one from Brian, though, why the 50% target? Again, it's sort of an arbitrary thing. We just set out a flagpole, a benchmark to try to really validate and test our models. We could have picked 55%, 75%. Just, with that, we would expect more nights of action, whether it's a forecast dynamic alert or an interval of time to capture 75% is just going to require more time. But 50%, it wasn't necessarily dictated by conservationists on the ground or building managers. Again, this was sort of in many ways an academic exercise to see how good we could do with a modeling approach. But it would be, you could tweak that metric across the US to say we need more or less. But effectively, the Birdcast alerts that we deploy operate on this type of strategy of trying to capture those top 10% really important nights is how we're running things.
Okay. There's another question that just came in about, the question is about Swainson's hawk migration. And do they migrate? I don't know what the question exactly is, but migrating by day, by night?
Yeah, I'm happy to talk about Swainson's hawks any day. Yeah, so I don't know what the question is. I'm happy to, if you expand on, chat about that as well. But Swainson's hawks are primarily a daytime migrant, which is true of most birds of prey, hawks, falcons, even turkey vultures. These large soaring birds utilize a lot of the upwellings, the thermals from within the atmosphere as the sun heats the surface of the earth. Those warm airs rise, and those birds with generally larger wings will soar on those thermals. So Swainson's hawks have their own suite of conservation issues, from pesticides in the tropics to agricultural pesticides here in the US as well. So depending on your question, I'm happy to chat, but hopefully that gives a little, at least some flavor of Swainson's hawk things.
Tim wants to know if you looked at light pollution from the oil fields in the Dakotas.
Yeah, that's a good question. So just for a little bit of background for everyone here, if you look at a light pollution map for North America, for instance, basically what you see is places where people live lighting up brightly. That's probably no surprise. New York City, Denver, Houston, Chicago, you name it, big cities are bright. The anomalies here are places like the Dakotas. Again, very low population centers. There's not many large cities, but it's really bright. And the reason for that is related to the petroleum industry that has ballooned in the last decade or so. We haven't looked at it. We've thought about this for a number of different reasons, again, because it's one of these areas that's a little bit detached from urban centers. But one of the challenges that we face is that we don't have excellent radar coverage in those parts in the Dakotas. Generally speaking, there's more radars in places that people live. So as you get to more rural areas, you see fewer radars on the landscape. This is especially true in the Western US, but so the eastern half of the US is pretty densely populated with radars. In those areas of the Dakotas, we just don't have great coverage, so we haven't been able to assess that type of question. I don't know if we'd be able to see a signal regardless, but it's a really interesting point. So thanks for that question.
Okay, the question about, well, more on Swainson's hawks. It said a couple of weeks ago, Don saw about 20 flocking for migration. And that, my understanding is they do travel in groups, in kettles. And he said, what would you say about the Swainson's hawk migration and characterize it?
Yeah, I'd echo what Polly mentioned here as well, that they do tend to move in pretty dense clusters, depending on where you're at in the US. So when I was in Oklahoma, we'd see fields of them. There might be 100, 200 Swainson's hawks munching on, probably large, crickets, grasshoppers out there, maybe some small like voles or mice after a field had just been plowed and sort of tilled, things like that. But they do move in pretty dense concentrations.
Is there a certain time of night that most birds migrate? I mean, we've been telling people 11 at night to 5 a.m. for lights out. But
yeah, right? It's quite variable. So there's some obvious takeaways here, right? If you're around the Gulf of Mexico in spring, birds take off and there's no birds, behind them, right? Because there's a gulf. So it's going to take a while for those birds to cross the gulf and basically arrive the next day during the daytime. So once you get the main burst, birds usually take off about 45 minutes after local sunset. It ramps up about 3 hours into the night is going to be the peak of migration. And then you start to see a gentle decline in the activity. Some birds might go all night. Some are gonna just exhaust some of their resources, their energy resources, and maybe they'll fly for 4 hours or 5 hours. Some might go 8 hours, some might go even into the daytime. So it is variable, but I would say it peaks around 3 hours after local sunset And then your guess is probably as good as, what the actual birds are doing, how many hours after that interval they're going to keep going. It does start decline after that, though.
Oh. Okay. Claire asked if you what are some of the follow-up questions your team came up with out of these studies that you hope to be researched in the future?
Yeah, those are the things that keep us going. So each study just seems to fuel more questions and more uncertainty. So you learn one thing and then you have questions about three others, and that's true of most science as well. So, a question we often get when we talk about light pollution is, we can think about strategies. Light pollution on, off, that's going to be an obvious binary decision there. But are there different measures that we could think about to reduce collisions, for instance? So if you had really bright yellow lights versus really bright blue lights, like LED lights, does that change the mortality events, the attraction to light pollution? Does just dimming the lights have a really effective measure and a signal on attraction or collisions at buildings? Blinking lights versus stationary lights is always a consideration, or white lights, blue lights versus red lights at night. There's all sorts of interesting questions along those lines that I think are, ripe for study at this point. And it's just, time and energy basically are the things that we just are always running up against to work through these questions. But there's, I could go on and on for probably hours about the questions we have.
Okay. Right now there aren't any more in the chat, but I have one. Where do most, let me see if I can phrase this. At what level of a building do most birds collide? Is it lower down or is it higher up?
Yeah, that's a question I probably don't actually have the answer for. So when I talked about the Chicago study at McCormick Place, that building's actually a fairly low-rise convention center, at least where the monitoring was done by folks at the Field Museum. It's about 3 stories high. We don't actually know from those data when the birds are hitting the windows. We don't know if it's really early in the night, if it's just as the sun's coming up. It's likely in that scenario that they're hitting low, probably the first story. Just there's some structural things going on there that it seems like it's probably the first story, maybe the second story, the way the windows are laid out. But thinking about a skyscraper, for instance, I don't know if anyone knows those what's going on there. It seems like they're low, but it's likely that some of those birds are probably colliding, in mid-flight type of thing. But I think there's lots of work to be done there.
Do you have any information about wind turbine collisions?
Yeah, I don't know where I didn't see the question or the exact details of it, but in terms of turbine collisions, I'm always cautious of thinking about that. There's, an interesting divide here, right? It's a good source of clean energy. It has, relative to all the other threats that birds are facing, probably has a lower impact on bird populations. So things like cats out on the landscape have a really strong impact on birds, especially migratory birds, or light pollution collisions with structures like houses, residences, collisions during the day. Wind turbines obviously are causing some mortality, but the story probably gravitates more towards bat collisions as really impacting bat populations instead of bird populations at this point. But it's something really important to keep track of as the US grows its wind energy sector, that number is only going to go up. So there are ways that we could apply the lights out alert strategy to also wind turbines too, to say, this is a big night of migration, maybe halt the rotation on this night, but the other nights when there's low activity, maybe it does run through the night, for instance, and that's a good balance between good, clean, green energy. They get to produce some profits, but then also mitigating the threat on migratory birds.
We do have a couple of questions from Benjamin on the alert process. He was wondering where the alerts go and if we can measure the impact on human behavior. And he's also wondering about, he acknowledged that the radar data is incapable of identifying species, but can we use known migration patterns to adjust the alerts? And additionally, just talking a little bit about the compliance of the alerts and how the alerts work.
Okay, I'm going to try to tackle all of them. Okay, yeah, great questions, Benjamin. So where the alerts are going, the alerts are fairly passive at this point. So alerts go up onto the website. You can sign up for some cities. It's not effective, or at least it's not up and running for all cities across the US. You can look up alerts for all the cities in the US. You can go to birdcast.info. I think someone put the link in here. For some cities, you can actually sign up for an email that you'll get an email that comes out midway through the day saying, tonight's a big migratory event's coming. We're predicting strong migration. This is a lights out warning type of thing. That's true for a number of Texas cities right now. So we're expanding that over time. Each season we add additional cities. The compliance is always a challenge of what folks are actually doing. So we try to get the message out the best we can on things like social media channels, the Birdcast Twitter page. We're putting out alerts when we see the biggest movements coming. But we can't necessarily say at this point whether or not it's working, at least with the data we have. That's not to say that it's not working or it is working. We don't have an answer to that question. And in many ways, the project that I discussed on the last slide is trying to get at that very specific question. If we put out an alert and a message to a certain area, do we actually get compliance? And is there a better way to get compliance? Maybe an email is not the best way, but maybe a text message is, for instance. So we don't know the best mechanisms for this. We're at an interesting frontier of a new conservation problem and trying to come up with new solutions with better technologies. So that's going to be some of the things we're trying to do in the coming years of actually going out, trying to monitor light pollution within neighborhoods. If they get warnings, does the light pollution go down or up? Hopefully not up and hopefully down, but we'll see what we actually see in our data. I can't remember all of the tentacles of the other. Oh, there was another one about sort of curating the alerts maybe to other threatened endangered species. There might be some of that we could link in community science data that is species specific, like eBirds, for instance. And when those birds are on the move, can we shift the alerts to different things? That might be possible. We haven't dabbled with that yet. Right now, what we're trying to do is protect really the bulk of nocturnal migrants and not specific species at this point. But you can imagine you could cast this in lots of different ways. Good question.
Okay, we have one about whether birds can detect polarized light. And if so, do urban environments have high degrees of light polarization?
Yeah, that's a great question. I suspect there is some perception of this. Birds use polarized light for navigation purposes, thinking about polarized light that comes from natural sources like the sun, for instance. So I think there is some component. I don't know. I'm sure they're out there. I'm probably just not aware of them. Studies on this very specific thing with artificial, lights that are polarized potentially. I just don't know enough about those mechanics at this point to maybe answer that question. Yeah. Again, add it to the list here of things that I don't know.
Well, there's always a lot.
Yep.
Don't know. Vicki is asking if you and your group have given this presentation to city building owners, city planners and developers, ever in Denver, anybody in Denver that has seen it?
I haven't. This is my first Denver specific talk. So if folks want to point me in that direction, I'd be happy to. I just don't know. All of you probably know, obviously, that community much, much better than I do at this point. So if you want to shoot me an email, I don't think it should be too hard to find my email out there. Shoot me an email and I'd be happy to set up something and chat with that community as well.
Right, great. Goodness. We keep getting more questions.
Sure.
How did you start to be able to identify the difference between a bird and precipitation? That you made water bird for radar detection.
Yeah, that's a fun question. Visually, it's very, very apparent to humans. When we screen data, that's actually how we started. I used to, as a grad student, screen all of my data manually. That amassed to hundreds of thousands of images I used to go through to screen if it had weather contamination or not. That advanced very quickly as we got better tools where we actually could train models, in the vernacular of current computer science, that's machine learning techniques or computer vision techniques that can discriminate the unique characteristics of a pocket of rain versus a pocket of birds. They have different intensities, different textures, from the radar standpoint, different polarimetric properties that allow us to quickly separate them. But it was a historical challenge. I went through all my graduate school just manually doing a lot of these things. And then in the last 4 to 5 years, we've automated basically all of these processes.
Question. I'm not seeing, I think we've got everybody's question. I'm not seeing any more here. Let's see.
I saw the Amber Alerts question up here.
Oh,
what
yeah.
about using Amber Alerts? I'm not going to touch that one because that one sort of operates in a different importance of that sphere. And I don't, I imagine there's some government interaction with, all of these phone operators that rises to a very specific level of importance. But that's not to say we couldn't, do an app that would then push a notification that you could, actually enroll in. In many ways, that's how we operate the emails. But I think you're right that something that comes on your phone, just before the sun sets or something, wherever you're at in the US, would probably incentivize people more than an email, because we get so many emails these days. Maybe just a quick notification on your phone would sort of, ring the alarm a little bit, to say, oh, I'll go turn off my porch light tonight. Something as small as that measure goes a long way. Good question.
Well, we've got lots of thank yous here. Thank you for the great talk. Lots of those, and it really was helpful. I had a question. Have you done this in Fort Collins? We talked about doing it in Denver to building owners and managers or the city government or anything. Have you ever tried it in Fort Collins?
I may have. I haven't talked with Fort Collins sort of building side of things or city planning at this point. I've chatted with through the initial Lights Out Colorado. We were doing some talks like this in a shorter circuit. So I've chatted with the Fort Collins Audubon Society in a short venue. But again, I think there's lots of work to be done on the ground here in Fort Collins and Denver and Colorado Springs and Boulder. So if you all want to send me emails of where I need to go talk, I'm happy to do it to help birds in Colorado.
Okay, well, I don't think we have any more questions. And we're just about to 8:30, which was our end time. So Susie, do you want to add anything?
Just want to let everybody who's still on know that I will send a follow-up email that includes all of the links that we have shared via chat tonight. Kyle will be getting a hold of you to make a few connections on some of the things that you're looking for and things that some of our city reps who joined us tonight are looking for. So we'll get some of those connections made as well. If anybody else has any additional questions, we have just about 4 or 5 minutes left, and we can certainly hang out for another minute or two in case somebody has something that they just thought of.
Yeah, and I'll sort of look out for those emails. Like I said, the project that we'll be starting with, folks like Houston Audubon, Georgia Audubon, Fort Collins Audubon, I'd love to chat with, whoever it is that we should be chatting with at Denver Audubon. We'll be hosting likely a spring meeting for those topics about light pollution next year, hopefully in person. So maybe a visit up to Fort Collins. Hopefully, fingers crossed, is in your future here, and then we can chat with folks from National Audubon to National Park Service, down to some of the smaller Audubon chapters as well, and try to get some movement on some of these topics.
Okay, we do have a last question. Do you have any idea about residential versus commercial development?
Yeah, so there is some information on this. It's not from work I've done. Scott Loss at Oklahoma State University has done a lot of this pioneering work on trying to wrangle these mortality counts from cities to residential areas. This is probably to no surprise when you just think about the numbers. More birds are dying at residential homes than they are skyscrapers. And that's just a numbers game. There are so many more houses with windows than there are skyscrapers with windows on them. But in terms of, one-to-one metrics, a high-rise building is likely to see more mortality than a single residential home, one-to-one. So if you could turn off lights at a large high-rise, you'd get a bigger bang for your buck if you could just turn out one or the other. But if we got, if we reduce collisions at homes across North America, that would likely help more in total than what we could do at high rises. Again, urban areas don't account for a tremendous amount of the landmass across the US. It's a high dense area that's probably dangerous or is dangerous for birds. So there are some metrics out there, and if you reach out to me, I'd be happy to share some of those papers if you're interested. Good question.
Excuse me. Okay, and it says, are the home bird deaths daytime or nighttime?
Yeah, I get the sense a lot of them are during the day, admittedly. So light pollution, might play some part of that, but a lot of these birds are moving around the landscape during the day, trying to see through the windows, seeing a reflection and colliding with it. Or, sometimes with our best intentions, a bird feeder a little bit too close to a window and there's collisions there. So a lot of them, I think, are happening during the day. Obviously, it's not all migratory birds that are dying. It's, resident birds, chickadees, cardinals, house finches that are residents that are colliding too. So there's some simple strategies out there that you can make a big, quick impact with a few dollars of, application. So some hanging string from that sits in front of the window goes a long way. It's cheap. It's a couple of dollars. You quickly get used to it. It seems like a distraction at first. Trust me, give it a week and you won't even see them anymore. You just habituate very quickly to dots on the window or a string, floating with the wind. It goes away quickly.
It's good to know. Well, I think we're going to round this up. It's just about 8:30. Thank you so much for a really great talk and lots of information. Lots of things to think about, and I think you probably will be getting some emails.
Great.
From people who still have questions. So with that, I think we'll end the presentation in the meeting.